Things are in motion all around us. Cars, planes, toys, even you and me. Even when we are asleep, we are in motion because the Earth zips around the sun at 65,000 miles per hour. That's pretty fast. We just can't tell because we're all moving at the same speed. Things that are moving are said to have kinetic energy. That is, a mass moving at a given speed will have a certain amount of kinetic energy. An object at rest has no kinetic energy, but it may have potential energy, depending on where it is. A parked car has no potential energy unless it is parked on a hill. A ball has no potential energy until you pick it up, and after you drop it, its potential energy is converted to kinetic energy until it hits the ground or another object. Potential energy is the same as stored energy. The stored energy is gravity pulling down on the object. When you lift an object, you exert energy which will later become kinetic energy when the object is dropped. My hand lifting the ball exerts potential energy when lifting the ball off the table. The higher the ball is lifted, the more potential energy is produced, forming a greater amount of kinetic energy when the ball is dropped. At the top of the hill, the ball has a large amount of potential energy, but has very little kinetic energy. The word kinetic is derived from the Greek word kinetikos, meaning to move, and the word energy is the ability to move. Thus, kinetic energy is the energy of motion, its ability to do work. The faster the body moves, the more kinetic energy is produced. The greater mass and speed of an object, the more kinetic energy there will be. As the ball accelerates down the hill, the potential energy is converted into kinetic energy. There is very little potential energy at the bottom of the hill, but there is a great amount of kinetic energy. The amount of kinetic energy an object has can be demonstrated by the Newton's cradle. If I lift and release one ball, when it collides with the other balls, the energy it has will transfer through all of them and cause just one ball to accelerate away from the other side, going back and forth until all the energy is depleted. If I lift and release two, I have now doubled the kinetic energy it has, as it bounces into the others, causing two to accelerate from the other side. You can clearly see the energy transferring from side to side and depleting as friction and air resistance soak up that energy, and the balls bounce less and less as time goes by.